Hello, everyone. I'm Matt Moore. I'm one of the founders and the CTO of Chainguard, and today I'm here with Kit Merker, who I go way back with. Kit, you want to introduce yourself?
Hey, Matt. Good to see you. Good to see everybody. I'm Kit Merker, CEO at Plainsight. We turn cameras into spreadsheets so you can focus on your vision.
Yeah, so Kit and I go way back, and he and I connected years and years ago. I won't date myself with how or Kit with how far back we go, but he worked with me on Google's container registry team years and years ago. And in some ways, he's has a sort of secret hand in helping us start Chainguard. He was the person who gave me the push to present the Google distroless images talk at Swamp Up years ago, which is one of the sort of pieces that sort of inspires what we do today at Chainguard.
All I did was try to invite you to come to Napa. It wasn't. I didn't realize it was going to be such a hard push and how historic that would be. But we got to drink some wine, and I was, we were talking about this before, but I was thinking about the moment when during that talk where you had built Docker containers and then typed the word Docker and pressed enter, command not found.
Okay, so without further ado, I'm going to run the push rule. So this is downloading my, I was practicing this morning and this didn't work because my Wi-Fi had cut out and it freaked me out. This is pulling down the distroless base, building my war file, overlaying it on top of the Docker image, pushing it up to a container registry. And you can see it's done. So now I'm going to show it running, but I can't do that on my MacBook because I did all of that without Docker installed. Special.
It was a cool thing, and has led to, I think, a really big shift in how we think about building and managing the supply chain into containers. It's cool stuff.
So I think we're here today to sort of talk about your role at Plainsight and how you're leveraging Chainguard. So why don't you tell us a little bit about what led you to Plainsight?
Yeah, Plainsight is an interesting company. It has had a long history, and me and my CTO Andrew Smith, we've been reimagining it as a software infrastructure company focused on the vision workload. And just like you have, data workloads and you have serving workloads and web workloads, vision is its own workload, and it's actually kind of a very special workload. One is it's all made out of video data, which is big, and most video infrastructure is designed for human consumption. So if you think about, streaming video, we want all the frames and smoothness, etc. Well, guess what? The robots don't need that. The AI actually doesn't need that kind of infrastructure. So one way I explain Plainsight is we're building Netflix for robots. We're building the infrastructure that takes cameras and turns it into data in a way that is cost effective. So, vision as a workload is really the big idea. We're taking the principles of building large scale, internet scale data processing and compute, but optimizing it for vision workloads, driving down the cost of all the different things that make vision AI expensive. Transporting video is one part of it. GPU usage is another. So resource management and optimization across GPUs. Finding ways to pre-process data on inexpensive hardware that's 1,000th the cost of GPUs. Just finding regions of interest, frames of interest, and using that small set of data, sending it into GPUs, LLMs, et cetera. That's a huge piece. And then integrating with existing AI. I don't know if you've been watching kind of what's going on in the market with AI. Literally
hot right now.
Since we've been on this call, I'm sure that things have changed. But agents are huge right now, generative AI, LLMs, and I have a core belief that the fundamental foundational models are going to keep getting better, and we're going to be able to actually leverage that. The challenge is, how do you make it cost effective? If you manage think of all the cameras in the world and all the GPUs and LLMs in the world, it's like there's a box in between. How do we connect that together? So we decompose that problem into a containerized solution. We created also a framework, a development framework we call filters, which combines models and code into a deployable package. It's containerized, allows you to run the same unit of vision workloads at the edge, in the cloud, on premises, wherever it needs to run, and to string them together into these pipelines that process data and connect to APIs, connect to LLMs, connect to GPUs. So you really get this kind of cloud approach to deploying computer vision. If you just have one little computer vision problem, you have one camera, one model, there's not much you can do. Once you scale that to, multi-stage data processing, many replicas, many, stores or facilities, you start to have this complexity that is directly derived from the scale, not from the complexity of the vision algorithm. So if you think about the place where Plainsight wins is the combination of relatively simple or deep, composable computer vision applications done at many, many replica scale. And that's really our focus right now. And I think it's a cool space to be in. I'm really excited. I've been here for just over a year. It's a lot of fun.
Yeah, I think we've talked in the past about this idea of like transporting video, right? Like videos are big, and like especially when you're talking about lots and lots of cameras across your entire estate, all of your brick and mortar stores, or all of your all the places you might have a camera that you want to apply this to, right? Like, and so not having to deploy that, suck all that data into a centralized service is I think interesting. And so how does that affect like your deployment model?
Yeah, it's one of the things is that any sort of vision workloads are almost certainly hybrid in some way. The whole point is to get video data from somewhere in the world. So wherever that data is collected from cameras, could also be user sessions. There's places this data comes in. Sometimes it comes in batch, sometimes it's streaming. And so that means we're always dealing with something at the edge. We're always shipping software to a customer. And then part of the goal is to moderate and modulate what data is actually sent to the cloud, as you've mentioned. So you might have a camera that's running 24/7. You've got, 10 interesting frames over this 24/7 period. So we're seeing sometimes we can compress it by, 99.99% of the data is ignored, and we trigger certain things. So we want to make a very simple way to kind of start and stop based on different events at the edge. That's one of the challenges I think that really leads to this container-based approach, is that you have to be able to give the software to the customer to run, and we also have to run it in the back end. We don't want to enforce them. It's like, oh, well, if you have an edge, you run it this way. If you have it in the cloud, you run it this way. You want to have one unified approach that these applications you can write once and run anywhere.
So what kind of challenges have you seen, handing your users these containers in order to run these filters, at the edge or in their environments?
Yeah. So the thing about it is that, customers today are very sophisticated when you give them software. SaaS is a different story. You can kind of hide things behind a SaaS. They can connect to the API and kind of like, go for it. But if I give a piece of software to a customer, they're going to run it through a scanner, and not my scanner. They're going to run it through their scanner. So they may choose, a scanner that I'm not familiar with. And there are many in the market that are available, right? Whether it's JFrog or Sneak or, any of the others that are out there. They all work just a little bit differently. And so the kind of traditional, sort of without Chainguard approach that we were taking is we say, okay, here's a container. They would give us feedback and say, oh, there's a CVE in this. I would say, trust me, bro. It's like that one doesn't affect us, right? And you kind of get into this whack-a-mole game where you're taking this security posture of, okay, those are, yes, we acknowledge those vulnerabilities are there, but they don't affect the code base, et cetera. And that's okay. And actually, like, that kind of was state of the market not too long ago. That's how things work. So what we looked at, and of course I knew who to call to talk about this, but Chainguard has always had this zero CVE mindset, and that's the way I look at it is that, look, if I want to eliminate the challenge of dealing with scanners, like, just don't give them vulnerabilities in the first place. Now, it does require some discipline because you got to stay on latest and kind of have to be up to date. Now, I could pay an engineer to go do that work for us, right? And say, oh, well, we'll just do it ourselves. But obviously, that's not core to our solution. It's important. It's critical to our success, but it's not core to what we're doing that's differentiated. I need my team to focus on building the vision infrastructure, the AI tooling, the agentic architectures, that this is what we have to focus on. And so we can kind of eliminate that from our workload. It's perfect. So that's really what we've changed. And that's been, pretty good for us. We've been on that for a few months now, and, primarily focused on the bits that we're shipping to customers. And that's really kind of reduced that back and forth in terms of vulnerability analysis.
Yeah, I mean, we do have a lot of customers where that's really their deployment model, because it saves them in some cases from, they aren't necessarily doing it for the same reasons as you are, that, it's expensive to upload video. Sometimes they're doing it because, it's expensive to go through FedRAMP themselves. And so they give customers, the solution to run and operate themselves. And some, large financial institutions just want to run things themselves, even if you're PCI compliant or whatever else. So yeah, I mean, I'd imagine you've had your own interesting adventures with this, with filters, right? A lot of the filters that you have are sort of industry vertical specific. Can you share some examples of some of these and how you, yeah.
Well, it is, yeah. So one thing I will add to that previous point is that, today it's mostly edge filters that we're shipping to customers, but our strong desire is to externalize the entire platform so anyone can run it on their own infrastructure. That's something that I think we'll be focusing on in the future once we get a little bit more mature. But today it's primarily edge plus, us running the cloud. Our dream, of course, is to ship the whole platform to customers running their own cloud environment. So on the question of use cases, this is a really interesting one. I'll tell you, CEOs and probably CTOs too get a lot of advice, unsolicited advice in the market. And if I had to tell you the number one piece of advice I've gotten from whether they're investors or mentors or random people on the street, somebody will stop me on the street and say, "Kit, you got to do. You got to focus on one vertical and you got to own that vertical." This is the number one piece of advice, and I reject it out of hand, of course, but I'll explain why. But I think the thought behind that advice is that focus, right? Focus is the reason. You want to focus on a thing and you want to do very well at that one thing. So how are you going to do that? And at Plainsight, we're definitely focused, right? And what I was describing before is thinking about vision as a workload. Many different enterprises, many different verticals actually have the same algorithmic challenges and process challenges, despite the fact that the video looks very different, okay? So, where we're seeing traction today, and I'm really quite proud of, is, livestock is one that is great. Livestock is especially when it's a large, slow-moving animal going down, a corridor, that is something where we can be very accurate and we can get really great data about it, whether it's sheep or goats or pigs or chickens or what, that this livestock industry for us has been one that we've seen really great penetration. In manufacturing, manufacturing, it's not a panacea for computer vision. People want a variety of different things that they're looking for. Sometimes the defects that they're looking for are very small or hard to detect through AI because there's not a lot of representative examples, et cetera. But manufacturing is an area where today human quality control, adjustments, et cetera, even just getting early warning signs about a production process that you can kind of pull the end on cord and shut things down to go and correct it. That's one that's seeing a lot. In the retail space, consumers restocking, et cetera, that's a big one. We're working with a customer that's doing convenience store theft detection, and so there's all these different kinds of places where vision is useful, whether it's transportation, logistics, et cetera. So we have this industry agnostic point of view. Now, you said like the filters probably are use case specific, and this is where we've really, I think, unlocked some magic. Okay, the filters themselves, the software themselves, this is really a infrastructure layer. It's really a foundational piece. We have utility filters. We've got sort of general purpose tools and SDKs, but we give the developer, right, our customer's developer, the ability to take our filter runtime, take a model which is really derived from data, right? So we're helping with that data collection vision lifecycle. We help them get from camera to annotatable data, which is its own challenge, by the way. Just the problem of saying I have this camera and I want to get the data ready to annotate. I'll give a plug to our partner Encore, which is an awesome annotation platform. That's our favorite one. But we take, camera to annotation, then you go from annotation to training, then you go from training to model, and then model, then you have to add code on top of that. Well, now we've got this filter runtime that's an abstraction that gives you a bunch of stuff out of the box, like how do I connect to the camera RTSP feed? How do I output subject data? How do I configure it? How do I, chain them together? All that's done in very sort of cloud semantic kind of ways, very Docker container Kubernetes friendly kind of ways, as you would expect. And then what the developer can do is take that runtime and add another layer to the container with their little bit of Python code that talks to the PyTorch server. And all of a sudden, they now have a composable solution. And they don't have to build it all as one monolith. They can think of the containers each as a single step, right? These filter runtime is a single step in the process. You might say, okay, first step is find the object. The second step is see if that object crosses this line. The third step is whatever. And you might have some other utilities, crop and rotate and region of interest and lighting and all these things that you can apply. You don't have to invent from scratch or write like this long application. And that's how we're avoiding the computer vision, kind of specific library. It's really a set of tools for the job that was ever increasing. And then being able to kind of on the fly compose it. And by the way, I'll tell you my dream, okay? My dream going to agents is that you can just write a prompt, okay? And the prompt will generate all the configuration with a RAG. Hopefully our audience knows what RAG is and knows what prompts are, whatever, but I'm speaking agent talk, right? So imagine this, right? You say, okay, I got this camera and it says, if the person is wearing sunglasses on their head, please send me a text message, right? Yeah. So you can imagine what that would do behind the scenes. Okay, now we're going to generate the specification in our DSL. We call it spectacles, by the way. It's a cool name, specs, right? So sunglasses fit, right? So it generates the spectacles. That then turns into a configuration that can hydrate a pipeline in our what we call vision flow, which is like the pipeline. Give you the edge filter that connects to the RTSP feed, which is the protocol we use for video streaming. Everyone uses for video streaming. And then all of a sudden, guess what? That prompt turned into not just an application, but actually scalable vision infrastructure, which if you then said, okay, now connect it to, here's a library or here's a catalog of 7,000 cameras that I have. Now go look for sunglasses and all those people. It's pretty easy to imagine that could be done in a way that would be, also we could, protect the cost quota of the GPUs, etc. That's the big idea of what this could become. And this, I think, really ties into, as we look to the ERPs of the world, because we turn cameras into spreadsheets. What's a spreadsheet if not just an ERP system is just a spreadsheet, right? So you think of SAP or Salesforce or ServiceNow or any of these kind of systems, the agent layer, right? Being able to now bring vision to the agent layer. This to me is the really exciting idea, is to move us beyond chat. And the biggest limiting factor is that the cost of transporting the video and getting all of the kind of that pre-processing and everything in place means you just simply can't do it today. So this is what Plainsight's really trying. I'm sharing our strategy openly. Anybody can try to come at us, but that's what we're trying to do. It's like, yeah.
I mean, you know me, I love composition. I love, putting, I was a Lego kid, right? I love taking the blocks and putting them together. So the idea of like building these reusable things that you can stitch together and cater to different verticals is, it's my love language. I love it. So yeah, I mean, you mentioned AI agents, so hot right now. I guess, tell us more about how you think about this.
Here's how I think about this. I think that the LLM revolution, the generative AI revolution keeps on going. And I'll be honest, I was a little bit of a skeptic in the early days. And I have really come around to the fact that this is fundamentally changing a lot of things. I don't think it's replacing all developers in the world. Or, I don't think it's going to have some of the most extreme outcomes, but it's undeniable that this has changed the way things are working. And in fact, one thing I think about, people were talking about low code, no code a lot. And I think LLMs are the absolutely perfect low code solution out there. And so what I see happening right now is that a lot of it is focused on the chat experience. And I think that's very logical. They're using ChatGPT, text data, et cetera. And we're also seeing things like, speech to voice, this multimodal kind of stuff. Vision is a hard one. Vision is particularly difficult in this, especially when you're dealing with the bespoke enterprise use cases that don't have necessarily a high degree of public data sets, right? If you're inside of the manufacturing plant where they're making, a packaged food product, that's not necessarily a public training data set, et cetera. So the way I've been thinking about this is, one is what I call vision prompts, right? And so if you think about a camera, like we were kind of talking about before, but imagine being able to say to an agent, hey, when you see this, do X, right? And what you would not want to have happen, so if you make that request, when I see sunglasses, tell me, as we were talking about before, you would not want that LLM to continuously watch every frame of the video of every video in order to accomplish that task, right? What you actually want it to do is to generate a program that can be deployed to a less sophisticated system to do the simple task. And then when it sees the thing, to come back and turn on the video stream. That's what you really want it to do. And it could actually use a variety of techniques to look for that. It could use simple object detection. It could use some color detection. It can even use image classification. And image classification is a relatively inexpensive algorithm or model to use. So you would imagine delegating the control of identifying the frame of interest, right? And then when that frame occurs, then you can send the stream back to the LLM, to the agent. I keep kind of using LLM and agent interchangeably, but really the agent that's trying to perform the task that's built in the LLM, it could bring it back and do the higher context thing. Okay, now I completed step one. Now I need to do step two. What's step two? So now I've got all these integrations there. So really thinking about, instead of the prompt being prompt from human typing into chat box, prompt is, I have a higher order responsibility described as prompts, by the way, right? Hey, hey agent, this is your job now, right? That then derives to concrete infrastructure definitions that we all know and love. Like, it's like prompt to Terraform, kind of, what I mean? It's kind of the way to think about this, right? Very, very kind of straightforward. But do that in a way that's aware of those composable building blocks of the vision filters, and then deployed into infrastructure in such a way that it can pre-process and run these less expensive algorithms. So you get to power the agent with the sort of vision infrastructure as a pre-processing tool for it. And you can also imagine, like, I think one of the other cool use cases is user sessions. And I really could imagine for, let's say you have a support agent, right? And you're chatting with the support agent and you say, hey, my software is broken or whatever. And it says, well, show me, right? And then you go through, you show it, records your screen, and then gives you a knowledge base article or files a bug or whatever it is that it needs to do to help support you. Well, if I just take, raw, full screen recording and shove that into an LLM, I don't think that's ideal, right? At a minimum, I would want to do some downscaling, some frame reduction. There's some things I would want to do pre-process, but I would even go one step further. You might want to blur out file names. You might want to make sure that you're only looking at the tabs that are your tabs. You might want to do some pre-processing for privacy, security, and cost reasons, right? So that's the idea, is that now I've got this agent and I'm giving it these external tools to make it so the video data they're processing is much more targeted and much more relevant to the task that the agent is trying to complete, and then let the developers kind of create those guardrails and build the infrastructure around it.
Every CISO's favorite topic is how to protect, the data that stuff's being trained over.
100%.
Hiding the file names, hiding the access tokens and the secrets that accidentally get printed out on your screen, all the fun stuff. So,
yeah, I think there's a series of utility filters just for that, for the session sharing thing. But it's a big challenge, and the more we unleash this on the world, the more that stuff is going to necessarily leak. And that's why we have to think about security, privacy, ethics. We have to think about that up front. We can't wait for it to be a problem.
Yeah. I mean, I think the other really cool thing with, composing these things, is the ability to cost optimize things, right? Run the cheap things first, filter out the stuff that, is a clear, don't process this before you feed it through the more expensive models. And,
right.
Everyone knows, AI can get expensive, right? And so, making it, economical, I think, is definitely a big win.
It is. I'll be out. It's not just the big one. It is the big win. And when you look at the enterprise AI adoption market today, enterprises don't really have production grade mission critical AI workloads yet. I say yet, but it's really still an emerging thing. There are of course there are companies leading it, but I would say there's more of the the AI forward companies that have definitely shown more promise there. But if you think about companies that are really trying to drive AI adoption, and I believe, this is my belief, not just because of Plainsight, but I've looked at the market from every different angle, that the value is going to be unlocked by the video data. I really just think if you're a business and you have, thousands of restaurants, quick serve restaurants, or you've got facilities, et cetera, that there's a gap between the data that in your system that models your business, sort of like, your digital twin of your business, if you will, right? You have this like database or spreadsheet that models your business. There's a gap between the real world and that. And the best way to connect those two things together is through the cameras directly. So I think this is where we're going to unlock enterprise value. The problem, and this has been, I think, pretty well documented through research studies and other things, the biggest problem is that because of the cost of deploying computer vision, both in terms of the upfront cost to get training and accuracy, and then the secondary cost of GPUs and infrastructure and all that, these projects are non-starters at scale. So what ends up happening, and we've seen this time and time again, is that you see proof of concepts that show that it's like, yeah, this is possible. And you go, okay, well, what would it cost me to roll this out to all the locations? And the simple math is like, okay, camera times model per GPU equals cost. It's kind of like a pretty like, oh, a camera, I need a GPU, I need a model, at least one model, maybe I need 3 models, right? I'm looking for 3 different things. I need 3 different models. Okay, that means I'm gonna have to run those on 3 GPUs per camera. So therefore the cost will be, and quickly the zeros start adding up, right? And there's CPU versus GPU, the cost is like not just like 1 order of magnitude, it's like 2 to 3 orders of magnitude difference in cost. This is not like, oh, it's a little bit more to run on a GPU. Why don't we just throw over a GPU? It really is a significant difference. So if you imagine being able to take this at scale, and it doesn't scale down. I'll start off with that too. Like if you have 1 camera, you know what? Party on, like whatever. That's not what we're talking about here. If you have hundreds and thousands of instances, you have to take into account the infrastructure cost and the development costs and everything else. And you also need to be very organized about versioning and rollouts and rollbacks and failover. Like there's all the other sort of cloudy concerns that you and I both know and love. And then I'll throw in the mix, now I got edge too. So it's a complicated infrastructure problem. Okay. So our goal is that we're going to dramatically drive down that cost through some of these simple methods. Focus on regions of interest, focus on frames of interest. That's the easy one. Downscale images whenever we can. Eliminate data and pre-process data using simpler, cheaper stuff wherever we can, right? Before it goes into expensive hardware. Resource pool all the GPUs into like a PyTorch server cluster so that we can, do a priority queue to do job scheduling to say, use GPUs on demand. And, maybe in the future, we have one of our investors just launched a company called Compute Exchange, where you can auction off GPU capacity. And so like in the future, one could imagine that companies will start to buy and sell GPUs based on forecasted demand. So we think that this is kind of like where things are going, is that, it's expensive hardware, so therefore we need to be optimized. And that I think really is the key. Once that starts to materialize for people and they start getting business value, right? It only makes sense if you get a return on investment. ROI, I have to be careful. I can't say ROI because it's region of interest is also return on investment in the computer vision space. But anyway, the return
it's also radio on internet if you've watched Silicon Valley.
Let's go this way. Anyway, yeah, exactly. So the return on investment, there's 2 factors. One is, what do you get in terms of revenue growth, but the other factor is what do you get in terms of cost. Those 2 things have to pencil out. And so my belief and what we're working toward is like, let's just dramatically reduce that cost through smart, resource management, resource optimization, marry supply to demand, prioritize, reduce, reuse, recycle. And hopefully that will turn into incredible business value. And we're seeing it already. I mean, to be honest, we're seeing it already. And we're still early in this journey. But we have, a number of engagements where we're really excited about the early signals we're getting. And we're trying to build the best freaking product we can. I know that's your thing too. We always be shipping, as we used to say at Google, right? So there you go.
Yeah. For your customers who are deploying this to edge, like what kind of setup do they typically run on at the edge, right? What kind of crazy kinds of setups have you seen, or is it pretty regular?
Well, so this is one of the most interesting things. First of all, there's no consistency whatsoever. Okay, and that's like to start with that. But I have encountered some pretty crazy GPU setups. And I had this one company I was talking to where they're like, yeah, we just spent all this money on these GPUs for our manufacturing facility. There's one guy in the company that knows how it works, and we're all afraid to use it. And it keeps getting dust in the box. And they're like, what can we use this for? You know, and that's one for sure. I mean, one of the things we've pushed with customers is like, if they're going to buy GPUs, we tell them like, maybe don't. And we built this GPU-less edge that lets you do things that are algorithmic computer vision. So for example, right, you can use Meta's Segment Anything. I don't know if you've seen, but go to segmentanything.com. It's super cool. You can play around with it. Segment Anything allows you to take arbitrary images and create polygon segments out of them. And you can do this from a bounding box. So you have the ability to kind of on the fly define the region of interest you care about and look for variations in color or anomalies, right? So you can set events. This goes back to this whole prompt concept, right? So I have the ability to take a camera, take that image somewhere else, define a polygon that I care about, send it back down to the edge and say, hey, when something happens in this edge, turn on the camera and start sending me the feed, right? Very simple. That runs on CPU. So you can now think about, well, if all I need at the edge is a way of regulating the camera, turning on and off for things that I care about, and we can run simple models as well without GPUs. They run a little bit slower. You have to reduce the frame rate. You can't have as many embeddings, right? You can't have as many classes, but you can run lightweight stuff. And if you really consider this to be this pipeline architecture, where you say, okay, there's a little bit running at the edge, but the role of that is to turn on and off the camera. Its job is not to answer the question. Its job is to turn on and off the camera, and we can remotely tell it what to look for on the fly. Someday that will be an agent, but today that's done through configuration. And then it can go to a cloud pipeline that has a series of steps for frame reduction, frame deduping and object detection, and you can use GPUs all at once. And it can use third-party APIs, third-party LLMs, send it to OpenAI and ask higher order contextual questions with a predetermined prompt. All of that can all be built into that pipeline. So our goal actually at the edge is to dramatically reduce. I mean, our dream is that it just runs on the camera. If we have Linux-powered cameras, we can deploy a Docker container that is built on a Chainguard base image. Boom, right? We just push that out there, and then it's all of a sudden we've got camera to spreadsheet and the cloud in between, but it really could give us that level of power. So that's one conversation with customers that I'm really excited about, is when we tell them like, yeah, you might not need GPUs. They go, what now? Because their cost spreadsheet, when they have GPUs in it per store, it's astronomical. And good luck actually buying them too, by the way. That's the other.
Well, I mean, turning on and off the cameras, you turn it on and off the GPUs, right? If you don't need the GPUs on all the time, it's not just the cost of the GPUs, but the GPUs also suck power like it's their job. And so, there's that cost as well. And so
I also imagine it. So imagine you got all these little, like, I don't know, coffee shops, for example, that has this like expensive NVIDIA GPU sitting in it. Well, it's like the new catalytic converter of the coffee shop, right? Somebody's going in and like stealing the GPUs out of it. So I agree with you. There's the maintenance, the power, just the physical infrastructure, et cetera. This idea that you're going to take GPUs and all this GPU capacity so that you can run AI in stores, I don't think it's right. I think what's more likely is that we'll see a distributed GPU cloud, and I can imagine sort of vision at the edge being run at sort of the on-prem edge, but like in a cloud edge or a CDN. I think that's something that we'll see emerge, and I would be very excited to deploy kind of Plainsight vision edge into a CDN, GPU cloud CDN infrastructure to get close to customers. But even then, if we can reduce that requirement to CPU and reduce the total cost and make it much more elastic, I think it'll be a better solution. So this is where software and hardware have to come together. It's not just about like who's got the best model. If you think, agents, there's just software parts of this too. It's not just we got better AI. It's also who's got the better, more efficient, more elegant software solution too that can be adapted to these different things. It's so important. It's not good enough to just say, I've got models. There's a lot of focus on the model, the model is really directly derived from data. And that data needs to be captured and collected and everything else. So the same, if you think about this vision workload concept, right, and really defining it as a workload, it happens both before you even have a model and after you have the model, right? It's like running the model is part of the vision workload, but also collecting the data to train the model is a vision workload. And we Plainsight want to treat all of those vision workloads equally, right? We want to make sure that we have that first-class support that's elegant, well-defined, configurable, reliable, deployable, cost-effective, blah, 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 all the good stuff across any of those vision workloads, whether you're at the beginning of the journey, just trying to literally get your first video spliced up, ready for annotation, or you have models you've trained yourself for years, or you want to use third-party solution, any of those things, the filter runtime, containerized filter runtime is like I think a key software component of that, ties it into the Kubernetes ecosystem, ties it into the Docker ecosystem. I think it's the right way to do it. So,
toughest question. What's your favorite model? Or your favorite filter? If you had to pick one, like picking your favorite child, which is your favorite filter?
I think the sunglasses filter.
All
Matt,
right.
I have to plug you before we wrap up here, by the way, which is Chainguard Assemble. You guys are hosting your first user conference in San Francisco, and I luckily, I guess, I'm getting to be a customer lightning talk speaker, so that's exciting.
Yeah, it'll be fun to hang out. And I mean, it's going to be really exciting. It is, first user conference. We've got tons of customers coming to speak. You're also, unfortunately I'm gonna be up there talking about some of the stuff we've got cooking that we are announcing at Assemble. I hate the idea of like us talking about what we're doing. I love the idea of our customers talking about what we're doing.
Just imagine,
minimize me, maximize Kit. Perfect.
That's why we like it. Just imagine the young entrepreneur who shows up to this event and gives a talk that inspires their unicorn company like you did in Napa, right?
It'll be interesting. I mean, I was just thinking about my radio on internet comment in Silicon Valley. It was actually Richard Hendricks who was the guest speaker at, or the actor who played that at that Swamp. I forgot.
Thomas Middleditch, yes.
I completely forgot about that. It's just a small world.
I wish we had a recording of that talk. March 25th in San Francisco, if I'm not mistaken.
March 25th, at Convene. And you can register on our website.
I'll be there.
All right. Well, thank you so much for taking the time today to chat with me and, teach me all about AI and, rattle off many acronyms that I'm going to have to go look up after this, to be perfectly honest. But, I love, catching up with you. But, I also love to hear from our customers about how they're doing very interesting things that go in many cases like this, sometimes way over my head. And so, thank you so much for taking the time to speak with me today.
Thanks, Matt. Great to see you.